Hello, I'm Curtis Niddle, Vice President of Wired Technologies. On this edition of CableLabs Informed video blog, breaking news out of the Proactive Network Maintenance Project. Are those cable modems really doing what they're supposed to be doing? We're about to find out. That's our top story for today. Now, have you ever thought about the intelligence quotient of hybrid fiber coax networks? Probably not. Well, I'm here to tell you that we're about to make HFC networks even smarter using techniques that we call proactive network maintenance, or PNM. Now, operators depend on PNM to detect small network errors before they become big network errors and to fix those errors before they become service impacting. Now, what we need for this to happen is the cable modem needs to report PNM data according to the DOCSIS 3.1 specifications. It's not enough just to have the requirements in the specification. We need to make sure the cable modems are reporting that data according to the specs. And so to satisfy that need, we're leveraging the Common Collection Framework as a foundation for a brand new tool to determine whether the cable modems are doing just that. This tool is known as the Cable Modem Validation Application, or CMVA. And now here's Jason with more on this story.
The Cable Modem Validation Application, or CMVA, automates the PNM portions of the PHY and OSSI acceptance test, or ATPs, which is how the industry guarantees cable modems meet the specifications. The CMVA also lets you explore and validate cable modem capabilities in general, so you can troubleshoot and understand system behavior. Here is how it works. As you see here on the home screen, we can select the test procedures that we wish to test. I will just show some of the more interesting results, even though the full set of acceptance tests are automated in the tool. Here is the main page for the application. We set upstream, downstream, and other network settings. Some of this information is necessary to verify the responses from the modems, and some of it is necessary to run the tests. Let's run a PHY test. The full test right now includes RxMER and RxPower. The symbol capture test isn't enabled as we don't have a CMTS that reports it properly, so the test can't be conducted according to the specification in ATP. This test takes a couple minutes to run as it collects several RxMER samples. Here are the results for the modem we tested. Notice everything looks good for this modem, and everything passes. We see the results here in the table, and we can examine the graphical output too. Now we can run an OSSI test. All these test procedures are available to use, but we will just run a couple to save some time. I will run the popular FEC and spectrum analysis tests. Here are the results. It passes, and we can see a clear response in the graph. We've put a whole bunch of data visualizing results in the application so users can see for themselves what is going on. The output might pass the test, but the user might need the added information to verify the test configuration, or to look for issues, or to troubleshoot when there is a test failure. Here are some more results we can examine. First, here is an RxMER result from our unimpaired test setup. Notice how this result looks good too. Now I will use the application to turn on the noise source, which is a necessary component in the acceptance test plans. Let's look at the impact of that noise on the RxMER results. The noise source impacts RxMER substantially. Here's our previous test result with no added noise. Compare that to our new test result with the noise added. And here is what the FEC summary, or FEC summary, looks like too. We also have a data previewer section. Here you can browse data results from multiple modems you have tested, or refresh results to update test data. Here's a modem we have that allows LTE ingress, and here is the LTE problem in the RxMER results. There are other graphs in here, such as a histogram plot. We have automated the PHY and OSSI acceptance plan testing and have all these great ways to visually confirm the data. So we figured, why not put a place for special testing that vendors or members might want. If a vendor wants to include a special measurement or check a combination of measurements for some special reason, we wanted to make a place for that and make it easy to include. An operator might also want to check additional measurements in special combinations, maybe define a measurement combination or special workflow that requires other tests. We made a place for that right here. As you see, the cable modem validation application meets the specific needs of the ATPs, and we can share it to enable others to use it to prepare for certification, validate results from others, and apply their own requirements for testing.
The important takeaway from this video blog is that cable modems will very soon have their P&M data reporting capabilities validated with this cable modem validation app. Now, members and vendors that participate in CableLabs Proactive Network Maintenance Project can get this software for free. That's all we have time for today. I'm Curtis Niddle, and on behalf of everyone here at CableLabs, thank you for watching.